The way the memory management unit operates, and let's say the address is 16 bits. Now, I mentioned earlier with 32-bit computers, the CPU would use a 32-bit register, which means it can add and subtract numbers 32-bit long. In addition to that, the 32-bit computer means that the addresses with which we reference the memory are 32 bits long. Which means that how many addresses do we have 32 bits long? I mean, how many 32-bit addresses there are? How many unique combinations of 32 bits do exist? To the power 32, right? Which is what? How much memory can we address? 2 to the power 32 gives us 4 gigabytes of RAM. That's why back in the 32-bit computers we couldn't have more than 4 gig of RAM because we didn't have a way to address it. But there were some software extensions that could address a little bit more memory. But with 64-bit computers, that's part of the reason we moved to them, is because we could have 2 to the power 64 memory locations. That's a lot more RAM than 4 gig. So now we get to have more RAM, because we always want to have more memory, because we want a lot bigger programs in there. And we want to run more and more programs at the same time. So in this case, our address is 16-bit. Just to try to visualize this, but imagine in your computer it's probably 64-bit. So we would split the address into 2 parts. We have a 4-bit page number and 12-bit offset. The page number is used as index in the page table. So this is split. 1, 2, 3, 4 bits is for the page number. That's the number of the page, and then we have an index to say within the page, where within the page we want to go. So that's an index or an offset number. The current address we have is 8196. If we convert this to decimal, it will be 8196. Incoming virtual address. The bit that you see here is present or absent bit. This means these pages are loaded in the memory, and the ones that have a 1 and the ones that have a 0 are not loaded in the memory. So this this is how the page looks like. We have this will show how many times this page was referenced or it's needed, and it's used to decide which page to evict from the memory. Modified is also called a dirty bit. This will show if the page has been changed ever since it was loaded. And if it has been changed, then it has to be reloaded again. Then we have some protection bits. This is read and write protection. if a program is allowed to read only, or if it can write to this page, to this memory. And then we have the page frame number. The page frame number is copied into the high order 3 bits of the output register. And then they will form a 15-bit physical address which is put out on the memory bus. Now, I just want to mention something, that there are hardware devices called translation look-aside buffer, which will help us to do a fast translation inside the memory map unit. So we will load frequently used pages into the translation look-aside buffer, and we first look if our page is there, and we load it from there instead of going to the disk, and that speeds it up a little bit. Okay, so I will change today's video case to midnight tonight, and next time